Imagine trying to solve like a three-dimensional puzzle blindfolded, right? Where getting it right cures a disease and getting it wrong means a decade of wasted lab work.
Yeah, that is a wildly stressful puzzle.
Right. But up until literally today, that was essentially the reality of biological science. But an AI just solved it in a fraction of a second.
Which is just staggering when you really think about it.
It completely is. So welcome, everyone. We're jumping straight into a custom-tailored deep dive built specifically for you today. And today is Friday, June 19th, 2026.
We've got a lot of ground to cover today.
We really do. We are looking at a massive sweep of AI advancements from the Daily Digest hitting the wire right now. And I mean, it spans biology, education, physical infrastructure, finance, and even like fine art.
Yeah, the sheer breadth of it is what's so fascinating.
Exactly. And what becomes immediately clear when you look at all this happening simultaneously is that we are crossing a major threshold.
We really are. I mean, if you look at the density of these developments, the whole narrative shifts. Artificial intelligence is no longer just, a discrete tool.
Right. It's not just a novelty anymore.
Exactly. It isn't a search engine you query or a chatbot you open in a browser. What we are witnessing right now, today, is AI becoming the invisible foundational infrastructure of our reality.
The background processes of human existence, basically.
Yeah, it's optimizing everything behind the scenes.
Okay, let's unpack this because to really understand that shift, I think we have to look at the absolute smallest scale possible.
Right, down to the microscopic level.
Yes.
Yeah.
So a team of researchers at MIT just announced a breakthrough deep learning model. And it predicts protein structures unfolding with a level of accuracy that is honestly staggering.
It really is a game changer for the scientific community.
And I know, like, mapping proteins sounds like a highly specific, kind of dry academic problem. But this has been the white whale of computational biology for half a century.
It has. And to grasp the magnitude of this, we really have to look at why it was so computationally impossible for so long.
Okay, lay it out for us.
Well, a protein is basically a linear chain of amino acids, right? But it only functions when it folds into a highly complex three-dimensional shape.
Right, the shape dictates the function.
Exactly. The way it folds dictates what it does, whether it becomes muscle tissue, an antibody, or part of a virus.
But predicting that shape is the hard part.
Oh, incredibly hard. The problem is, even a small protein can theoretically fold in an astronomically large number of ways. It's a concept called Levinthal's paradox.
Levinthal's paradox, okay.
Yeah. So if a supercomputer tried to just brute force the answer by calculating every single possible physical fold, taking a fraction of a nanosecond per fold, it would still take longer than the age of the universe to find the right one.
Wait, longer than the age of the universe? Just for one small protein?
Just for one? Yeah.
Wow. Which is why the old method of using those massive physical simulations was such a monumental bottleneck. Scientists were essentially trying to simulate the physical thermodynamics of every atom pushing and pulling on every other atom.
Which is incredibly tedious and slow.
Right. It's like
Wow.
trying to figure out how a wildly complex origami swan was folded just by looking at a flat piece of paper. But this MIT deep learning model isn't doing that, right? I mean, it isn't simulating physics.
Exactly, and that is the genius of this computational shift. Instead of simulating the physics step by step, the deep learning model uses pattern recognition on a massive scale.
Okay, so how does it actually do that?
Well, it looks at the vast evolutionary database of known protein sequences and structures. It relies on attention mechanisms.
Oh, kind of similar to the architecture behind large language models.
Exactly like that. Just as an AI learns the grammar of human language to predict the next word in a sentence, this model has learned the biological grammar of amino acids.
That is so cool. So it predicts which parts of the sequence are likely to be physically close to each other in 3D space.
Right. It reverse engineers the shape almost instantly.
So it's essentially acting like an incredibly advanced autocomplete, but for three-dimensional biological machinery. It sees the sequence of letters and immediately outputs the 3D blueprint.
Yeah, that's a great way to put it. And what's fascinating here is how this completely upends the timeline for drug discovery.
Because you don't have to wait years to see the structure anymore.
Exactly. Most modern medicines work by binding to a specific protein, like a highly specific molecular puzzle piece. So if a new virus emerges and you want to design a drug to neutralize it, you need to know the exact shape of the virus's surface proteins.
And in the past, that took forever, right?
Oh yeah. Experimental methods like X-ray crystallography could take years just to map a single shape. Now researchers can get a highly accurate prediction in minutes.
We are talking about shrinking decades of trial and error laboratory work down to literally a morning's computation.
Right. It fundamentally rewrites the timeline for discovering new medical treatments. It's about AI decoding the fundamental building blocks of life.
It really fundamentally changes our relationship with biology. We are moving from a state of observation and slow experimentation into a state of rapid, programmable engineering.
Absolutely.
And, what strikes me is that if AI can successfully map these incredibly chaotic, previously unmappable biological networks, it makes total sense that we are now aiming it at something arguably even more complex.
The human mind.
Exactly, the way the human brain acquires knowledge.
It is the exact same underlying principle of decoding complexity. We are moving from the architecture of the cell to the architecture of cognition.
Right. So looking at the digest, there is a massive initiative rolling out across schools in California right now. They are deploying AI-driven, personalized learning platforms.
And this isn't just about putting iPads in classrooms, which is what people usually think, is a fundamental restructuring of the educational model.
Now, I have to stop you there because I'm genuinely wrestling with this one.
Oh, really? Why is that?
Well, when I read about AI adapting curriculum and delivering tailored content to students, my cynical side immediately kicks in.
Ah, I see where you're going with this.
Yeah, because we've had adaptive learning software since, like, the 1990s. If you get a math question wrong, the software just bumps you down to an easier question.
Right, the old drill and practice programs.
Exactly. So my question is this new initiative actually changing the learning environment, or are we just looking at a hyper-glorified, algorithmic multiple-choice test that just keeps kids glued to screens?
That is the exact trap most people fall into when they evaluate educational tech today. But the mechanism here is entirely different.
Okay, walk me through it.
So those whole systems from the 90s and 2000s were essentially static decision trees. If the student fails Rule A, send them to Rule B. The AI platforms being deployed in California right now are building dynamic, localized, probabilistic models.
Wait, models of what exactly?
Models of each individual student's cognitive state in real time. It's a field called knowledge tracing.
Knowledge tracing. Okay. So it isn't just grading the final answer, it's analyzing the process of getting there.
Precisely. The AI analyzes not just whether a student got an algebra equation right or wrong, but the specific type of error they made.
Oh, wow.
Yeah. Did they forget to carry the negative sign? Did they hesitate for 40 seconds on the division step? The AI identifies the exact microscopic gap in their conceptual understanding.
So it's diagnosing the specific point of friction.
Right. And then it dynamically generates the exact type of practice needed to bridge that specific gap, using concepts like spaced repetition to ensure the memory actually sets.
Okay, that makes sense computationally. I can see how that's powerful, but how does that not just isolate the student completely? Doesn't this make the human teacher kind of obsolete?
Actually, no.
Yeah.
The data coming out of California shows it does the exact opposite.
Really? How so?
Well, because the AI is handling the highly repetitive mechanical task of pacing and drilling, right?
Oh.
Which, frankly, a single teacher with 30 students could never optimize for everyone simultaneously anyway.
That's very true. You just can't teach to 30 different paces at once.
Exactly. So by offloading that, the teacher's role is elevated. The AI provides the teacher with a dashboard, which is essentially a real-time heat map of the classroom's cognitive state.
A heat map. That is fascinating.
Yeah, the teacher can instantly see that, okay, student A is struggling with a concept, while student B is actually dealing with a behavioral or emotional block.
Oh, I see. So it frees the human to do the high-level mentoring, the intervention, and the inspiration that an algorithm simply cannot provide.
Exactly. It brings the humanity back to teaching because the mechanics are handled.
So to map it back to the biology breakthrough, the industrial model of education was essentially a brute force simulation, trying to force 30 unique minds through the exact same curriculum at the exact same speed and hoping it works.
That's a perfect way to look at it.
And the AI acts as the optimization layer, decoding the individual pathways so the human teacher can actually be human.
Yes, it's systemic optimization. And once you realize AI can optimize these highly complex, multivariable environments like a classroom, you start to see how it can be scaled up
Scaled up to what?
to manage the macro infrastructure of our entire society.
Right. Which brings us to the physical world. There is a startup in the UK that is aggressively tackling climate change by integrating AI directly into the physical infrastructure of commercial buildings.
This is one of my favorite applications right now.
It's wild. They are using smart sensors to feed environmental data back to a central AI, which then drastically cuts carbon footprints by optimizing heating, cooling, and lighting.
It's a massive leap forward for sustainability.
But again, my cynical side. We've had programmable thermostats for decades. Nest thermostats have been around forever. What is the actual leap in logic here?
Well, if we connect this to the bigger picture, the leap is moving from a reactive system to a predictive reinforcement learning system.
Predictive. Okay, break that down.
A programmable thermostat just reacts, right? If the room hits 72 degrees, turn on the AC. The AI systems in these UK buildings are operating on a vastly more complex level of dimensionality.
So they aren't just looking at the temperature gauge on the wall.
Not at all. They ingest real-time weather forecasts, the angle of the sun at 2:00 p.m. on a Tuesday in October, the thermal mass of the specific concrete used in the building, and the live occupancy data of every individual room.
Oh, wow. So it's anticipating the environment before it even changes.
Exactly. Using reinforcement learning, the AI has essentially practiced managing a digital twin of the building millions of times to find the optimal strategy.
Practice makes perfect, even for buildings.
Right. So I realized that electricity is cheaper at 4:00 a.m., and the weather forecast predicts a massive heat wave at noon. So it super cools the concrete core of the building in the middle of the night.
Ah, so it acts like a giant battery for cold air.
Exactly. Allowing the thermal mass to absorb the heat during the day, which means the AC barely has to run when peak energy prices hit.
That is brilliant. It balances thousands of micro decisions per second to minimize energy usage without the human occupants ever actually feeling a temperature shift.
Yeah, it's seamless.
Yeah.
It cuts emissions significantly while offering huge cost savings. It's a win-win.
It is exactly like the building has developed a central nervous system. It isn't just a concrete box anymore. It is a hyper-aware organism that senses its environment and constantly seeks equilibrium.
I love that analogy. A hyper-aware organism.
And what is brilliant is that we are seeing this exact same biological concept, this autonomous background processing, being deployed in the invisible infrastructure of global finance, too.
Oh, absolutely. Major banks are utilizing AI in completely new ways.
Right, not just for customer service chatbots answering routine questions, but to act as a real-time immune system against global fraud.
The fraud detection aspect is actually one of the most mathematically intense applications of AI happening right now.
I believe it, because for decades, banking security relied on rigid rule-based systems. Like if a credit card is used in New York and then an hour later in London, block the transaction.
Right, but fraudsters know those rules and they constantly engineer ways around them.
And as consumers, we just hate the false positives. Having your card declined because you bought a coffee in a different zip code is just infuriating.
It's the worst.
So how does the AI actually bypass those rigid rules?
It uses high-dimensional anomaly detection.
High-dimensional anomaly detection. That sounds intense. What does it actually look at?
Well, every time you make a transaction, the AI isn't just looking at the amount and the location. It is projecting that transaction into a massive multi-dimensional vector space alongside billions of other transactions.
Wait, so it's comparing my coffee purchase to billions of others instantly?
Instantly.
Okay.
And it looks at behavioral biometrics, too.
Behavioral biometrics, like what?
Like the exact angle you typically hold your phone, the speed at which you type your password, your historical spending habits, and the incredibly subtle, complex patterns of known fraud rings operating globally at that exact millisecond.
Are you serious? The angle I hold my phone.
Yeah, it's that granular.
So it's hunting for microscopic deviations in behavior that a human security analyst could never spot in a million years, let alone in the milliseconds before a transaction is approved.
Right. It isolates the pathogen of fraud instantaneously.
The pathogen, okay, keeping with the immune system analogy, I love it.
Yeah, and this really highlights the dual benefit of AI at scale. Whether it is reducing global carbon emissions in physical architecture or securing international financial networks, human beings simply lack the bandwidth to process the required amount of data fast enough.
We just can't keep up.
No, we can't. AI is stepping in to handle the invisible, heavy lifting of modern civilization. It makes our massive societal systems fundamentally smarter, vastly more efficient, and undeniably safer.
It is an incredibly compelling vision of the future. I mean, we rely on the AI to map the proteins to keep us healthy, to pace the lessons to keep us learning, adjust the environment to save the planet, and monitor the network to protect our assets.
It's a complete paradigm shift.
It really is the ultimate triumph of logic, data, and optimization.
Mm-hmm.
But there is a final piece of news from the Digest today that frankly sort of breaks my brain.
I think I know which one you're talking about.
Probably. Because what happens when this hyperlogical infrastructure steps out of the realm of math, science, and optimization and steps into the realm of human emotion?
Ah, yes. You are talking about the intersection of AI and the creative arts.
Yes. Here's where it gets really interesting. A project just debuted where human composers and an AI worked together to create an original symphony.
It's a beautiful project.
It is, but they blended traditional composition with AI-generated melodic and structural elements, resulting in this completely unique, highly complex piece of music. And I have to be honest, I'm really struggling with this one.
It's definitely a controversial topic for a lot of people.
Right, because if an AI generates the core melody and a human just curates it, I genuinely don't know who the author is anymore. Doesn't this completely dismantle our conventional notion of what creativity actually is?
It absolutely challenges it. This raises an important question about the nature of inspiration itself.
Exactly.
But the mistake we often make is assuming that because the AI hasn't, lived or felt human emotion, its output is entirely sterile.
Well, yeah, that's the gut reaction, right? It's just code. It can't feel.
Right. But what the AI has actually done is map the mathematical topography of human emotion as expressed through centuries of music. It has mapped the latent space of creativity.
The latent space. Okay, meaning what? The underlying structure of all possible musical combinations.
Exactly. Think about a human composer. Even the greatest composers are limited by their own biases, their training, and the literal muscle memory in their hands when they sit at a piano.
That's true. You play what your fingers know how to play.
Right. They tend to fall into familiar chord progressions and structural ruts. But the AI has ingested millions of pieces of music across every genre and era. It isn't limited by human muscle memory.
It doesn't have a favorite key.
Exactly. It can traverse that latent space and find a melodic counterpoint or a structural variation that mathematically works, but that a human mind would never have organically conceived.
Wow. So it acts as a mirror that reflects possibilities we just couldn't see.
That's exactly it.
The source material doesn't actually describe the AI as a replacement, does it? It emphasizes that it acts as a collaborator, a partner in the creative process.
Yes, a partner that vastly expands the palette. The AI might generate 100 wildly unique variations on a theme, but it is still the human who listens to them, feels the emotional resonance, and decides, that one. That is the sound of heartbreak. That is the melody we use.
So the human becomes the curator and the director.
Precisely. The human still provides the soul and the intention, but the AI provides an entirely new, almost unimaginable set of raw materials to build with.
So what does this all mean for us? It means we aren't replacing the human spark. We are giving that spark an entirely new type of oxygen. It completely redefines how we express ourselves.
Which really brings us full circle through everything we've looked at today.
It really does.
It proves that AI's capabilities aren't strictly limited to cold logic and data crunching. Its ability to recognize impossibly complex patterns makes it just as powerful a tool for expanding human imagination as it is for predicting protein folds.
That is profound. Let's just take a breath and look back at the sheer ground we have covered today, because this hasn't just been a list of isolated tech updates.
Not at all. It's a cohesive narrative.
Right. We started with an MIT algorithm decoding the chaotic 3D machinery of biology. We moved into California classrooms where probabilistic models are decoding the unique learning pathways of individual human minds.
Then we looked at smart buildings in the UK using reinforcement learning to act as an environmental nervous system.
And global banks using hyperdimensional data to act as an immune system for our finances. And we ended up in a concert hall with humans using the mathematical landscape of AI to invent entirely new forms of beauty.
It is a sweeping testament to what this technology has truly become.
And to you, the listener, I want to emphasize why we built this deep dive for you today. When you look at all of this happening on a single day, June 19th, 2026, you realize that AI is no longer a tool you just choose to pick up.
It is actively reshaping the foundation of how we live, work, learn, and create. It is the new infrastructure.
The new infrastructure, absolutely.
And it leaves us with a profound question to mull over as we move forward.
What's that?
Well, what we have seen today is that AI has become exceptionally good at the how to fold a protein, how to pace an algebra lesson.
How to thermodynamically balance a skyscraper.
Exactly. How to secure a global network, and even how to structure the notes of a symphony.
Right, so where does that leave us?
If AI can perfectly optimize the physical, mechanical, and computational how of our reality, what does that mean for the future of human effort? As the machines completely master the how, perhaps our most vital, uniquely human skill moving forward will simply be deciding the why.
Deciding the why. Wow. From
Wow.
the microscopic architecture of our cells to the emotional resonance of a grand symphony, the infrastructure is built. Now we just have to decide what we want to do with it.
It's an exciting time.
It truly is. Thank you so much for joining us on this custom deep dive. We hope it gave you exactly the perspective and those aha moments you needed today. Remember to stay curious, keep exploring, and we will catch you next time.